Ever wondered what it really takes to build the AI that's changing our world? Yeah, forget all the hype and the mysterious black boxes for a second. Today, we're going to break down the complete 2025 roadmap. This is a clear path from the absolute ground floor all the way to the very frontier of artificial intelligence.
Look, this is so much more than just slinging code. It's about being the person who actually builds the next generation AI. The stuff that could revolutionize healthcare, completely transform how we create art, or just redefine entire industries. This right here, this is your entry point to that whole journey.
It's the big question, isn't it? But you know what? The path is surprisingly methodical. We're about to pull back the curtain on the entire process, breaking it all down into clear, manageable stages. Let's start with what this role is even all about.
Okay, first things first. Before we even think about diving into code and algorithms, let's nail down what an AI engineer actually does and why this role has become one of the most critical and, yeah, valuable in the entire tech world.
So here's the key thing to get. AI engineers are the builders. They're the ones who take these brilliant, theoretical models from research papers and turn them into tough, scalable systems that actually work in the real world. We're talking everything from powering your favorite app to detecting diseases earlier than ever before.
You can think of it like this. A data scientist is kind of like a detective, digging through data to find these incredible hidden insights. The AI engineer? They're the architect and the construction lead who builds the high-performance engine that puts those insights into action for millions of people. And yeah, the rewards for having these skills are absolutely huge. When you look at the numbers, you're talking salaries that start well into six figures, even at the entry level. They quickly climb past $200,000 and can even skyrocket to over $750,000 for those top-tier senior engineers.
You wouldn't build a skyscraper without pouring a rock-solid foundation, right? Well, for an AI engineer, that unbreakable groundwork is pure math and statistics. You just cannot skip this part, and here's exactly why.
These are the two killers you've got to master before you write a single line of AI code. Seriously, they are the language and the logic that control how every single intelligent model thinks, learns, and makes predictions.
Think of it this way. Linear algebra, with all its vectors and matrices, is literally the language that neural networks use to see and process the world. And calculus? Well, that's the engine of learning. Those gradients are the signals that tell the model exactly how to get better with every single example it sees.
And statistics, that's how we know if our AI is actually being smart or if it's just getting lucky. It gives us the scientific rigor to handle uncertainty, to interpret data the right way, and to prove that the results we're seeing are real and reliable. It's basically your built-in truth detector.
You've probably heard this old saying, and let me tell you, it has never been more true than in the world of AI. An absolutely brilliant model fed bad data will always produce bad results. And that's exactly why our next step, all about the craft of handling data, is so critical.
Okay, so with that mathematical foundation locked in, it's time to get our hands dirty. We're going to start working directly with data and building our very first predictive models. This is where all that theory really becomes practice.
A great AI engineer has to be a master of data. That means knowing how to find it, clean it, and prepare it perfectly. But the real magic, that happens in feature engineering. That's where you creatively transform raw data into powerful signals that make your models dramatically smarter. Now, before you jump straight into the flashiest, most complex neural networks, you have to master the classics. Traditional machine learning, with these super powerful and efficient algorithms like decision trees and gradient boosting, that's your essential toolbox. It can solve a massive range of real-world business problems. All right, now that we've got those fundamental tools down, it's time to seriously level up. We're heading into the world of deep learning, the engine behind pretty much every major AI breakthrough you hear about today. Deep learning just takes everything to a whole other level. It thrives on massive data sets. And, this is the key part, it learns the important features automatically, right from the data itself. This allows its complex, layered architectures to find patterns that are way too subtle for any human to define by hand. So to build these things, you've got to understand their blueprints. We're talking the architecture of neurons and layers, the training cycle where the model actually learns. That whole process is called backpropagation, where it basically corrects its own errors, and the advanced optimization algorithms like Atom that make this all happen fast and efficiently. We've covered the bedrock, we've covered the core tools. Now let's talk about the absolute cutting edge, generative AI. This is the tech that's powering those incredible tools you see everywhere, like ChatGPT, DALL-E, and Sora.
The pace of change here is just staggering. The introduction of the transformer architecture back in 2017 was the real game changer. That was the spark that lit the fuse on this whole revolution, leading directly to the explosion of powerful large language models we're seeing today.
So what's the secret sauce of the transformer? It's this thing called a self-attention mechanism. Now, in simple terms, this lets the model look at an entire sentence all at once and figure out which words are most important to every other word. This creates this deep, nuanced understanding of context that older models could only dream of.
Building with these giant models is a whole different ballgame. It starts with a massive pre-trained model, which you then fine-tune for your specific task. From there, you're optimizing its performance with clever prompt engineering and advanced techniques like RAG. That stands for Retrieval Augmented Generation. It's almost like giving the model an open book test, letting it pull in live external data to give you the most accurate answers possible.
We are almost at the finish line. But look, being a truly world-class engineer isn't just about knowing all the theory. It's about combining that knowledge with the right practical tools and, just as importantly, a strong professional compass for how to build things the right way.
Okay, so this brings together the final pieces of the puzzle. Python is your language of choice, PyTorch and TensorFlow are your go-to frameworks for building, and AI governance, that's your guide. Building systems that are fair, secure, and respect privacy isn't just a nice-to-have, it's a core professional responsibility, just like writing clean, efficient code.
And that brings us to the end of the map. We've journeyed from the first principles of math all the way to the very frontier of generative AI. You have the roadmap, so the only question left is the most important one of all. What problem will you solve that no one has solved before?